Okay, gentlemen, as promised, I'm going to go over some concentration word problems. These are the same problems that we did in class for those that were in class for this. But I think it might be good to have this recorded so you could go back and review it at your own speed. So we're going to look at concentration mixture problems. These are going to be problems where we're mixing two things. Could be something that we are physically mixing, or it could be more of a theoretical mixing, a mixing of two different types of investments. So we're mixing two things that each have a different concentration. They each have a different percentage of some substance. That substance could be, for example, hydrochloric acid. It could be milk fat. It could be stocks in some kind of mutual fund. So we're mixing these two different concentrations to get a different concentration somewhere in the middle. So let's look at an example. Same example we worked in class. We're going to mix two different types of paint, dark blue paint and light blue paint. So the dark blue paint is say 24% pigment or coloring, whereas the light blue paint is only 6% pigment or coloring. Now if I mix these two things evenly, the resulting concentration would be directly between 24% and 6%. So we'd split the difference. We'd meet it in the middle. It would be a 15% mixture. And if I put a little bit more dark than light, then my concentration would be a little bit greater than 15%. If I had a little bit more light paint than dark paint, it would be a little bit less than 15%. You can see in this problem that my result is going to be just 12%, and I want 500 gallons altogether. So the question is, how many gallons of each are needed? So let's say X is number of gallons of dark, and Y is number of gallons of the light. Well, I need 500 gallons altogether. So right away I know that I have this equation. X plus Y equals that total amount. For these basic concentration mixture problems that I'm going to give you, you will have an equation like this for every single one of them. X plus Y equals total amount. Write that down. You will always have X plus Y equals total. Now my second equation is going to talk about the total amount of whatever this important substance is. In this particular problem, the important substance is pigment. So if I have X gallons of dark blue paint, how much pigment do I have? 24% of X. And if I have Y gallons of the light blue paint, how much pigment do I have? 6% of Y. How much pigment do I want in my total amount, in the total 500 gallons? I want 12% of it to be pigment. What's 12%? Just a little side work. What's 12% of 500 gallons? Well, 0.12 times 500 is 60. So in that final mixture of 500 gallons, 60 gallons of it are just pigment, pure coloring. There's my system. So they seem a little bit complicated, but every single concentration problem is going to be like this. X plus Y equals total. Concentration of X plus concentration of Y equals the concentration of the total. So I would solve this system. It's a little bit trickier. I'm going to need a calculator, I think. I think I'll multiply the top equation by negative 0.06. So I get negative 0.06x minus 0.06y equals negative 30. Second equation, I don't need to change at all. Combine like terms. I get 0.18x, the y's are eliminated, equals 30. And then x must be, need a calculator, 30 divided by 0.18 is 166 2/3, or 166.6 repeating. So then what's y? Well, y is 500 minus 166.6 repeating. So y is 333 1/3. So if I want 500 gallons of 12% medium blue paint, I need to use 166 gallons of the dark, 333 1/3 gallons of the light. We'll look at a similar example. Now I'm mixing tea, diet tea, which is only 1% sugar, sweet tea, which is 4% sugar. How many ounces of each are needed to make 64 ounces of 2% sugar tea? Okay, how many ounces? X is number of ounces of diet, and Y can be number of ounces of sweet. I need 64 ounces altogether, so X plus Y is 64. And then I want you to think for a moment. I'll just give you a pause. You can pause the video if you like. Think about what your second equation is going to be. You've got your different concentrations and your concentration of the total. All right, so hopefully you said it would be 1% of X, 1% of the diet, 4% of the sweet equals 2% of the total. And what is 2% of 64? I need the calculator for that. I get 1.28. Right? Again, I'm going to use elimination. I have a lot of choices. I could multiply the top equation by negative 0.01, by negative 0.04. Some people might choose to multiply the bottom equation to make it an integer, clear the fractions. You have a lot of choices. I don't know. I don't really want to deal with decimals, so maybe I'll multiply the bottom by negative 100. So my top equation is unchanged. My bottom equation becomes negative 1 minus negative 1x minus 4y equals, how about negative 128? So negative 3y equals negative 64. I need the calculator. It looks like I'm going to have some kind of repeating decimal again. 21.3 repeating. All right, if y is 21.3 repeating and x plus y equals 64, then x must be 42.6 repeating. So to get this desired mixture, I would use 42 2/3 ounces of diet, 21 1/3 ounces of sweet, and I'd get 64 ounces of 2%. Somewhere in the middle. Notice it's a little bit closer. 2% is a little bit closer to 1%, so I'm using more of the diet than I am of the sweet. All right, I hope that helps. If you need to rewatch that, slow it down, pause it. Use this as your guide when you do these practice problems. Good luck, fellas.